Okay, so we defined curl of f of a vector field in the last video, and we showed that the curl of a vector field is again a vector field. But I want to give now a physical interpretation of the curl. So here's how you can think of the curl. So let P be a point, so x, y, z is a point in space somewhere. So if we imagine that f represents the velocity of water in a river, so say we're in a river and it has different currents at different points, so say white water or something, then the curl of f at point P points in the direction the axis of a paddle wheel must be oriented at point P in order to maximize the RPMs. So how quickly, RPMs means how quickly it turns per minute, revolutions per minute. Moreover, the magnitude of the curl, so again the curl will be a vector, so the magnitude of the curl gives you the max RPMs. And just note here, the paddle wheel needs to be completely submerged in the water. Okay, so let me show you an example here. Okay, so here's our first example. It says find the curl using the physical interpretation, then verify answer using definition of curl. So our vector function here is just 0i, x, j, 0k. I've drawn some things here, so you might ask how I did that. Well, if you evaluate, sorry, I wrote something incorrect here. Just erase this for a second here. If you evaluate, say, so assuming this is the x-axis here, y-axis here, if we went to f of 1, 1, 0, well, the function is just 0 in the I, so it'll be 0i, then it'll be x, and the j, x here is 1, so it'll just be j, and 0 in the k. So it'd just be j. So you see at 1, 1, so 1, 1, 0 would be right here. You'd have a vector j, so my vector j is pointing in the j direction, so it's here. And for example, say this one here, that would be, say, f 3 in the x, then up here this is 2, and say 0. So plugging into this, it'd be 0i, so it'd be 0i plus x times j, x here is 3, and 0k. So it'd be 3j. So 3, 2, 0 would be right here, that point. And at that point you're going to draw the vector 3j, which is right here, the vector 3j. And the z-axis is coming up this way, so up this way here. So you can imagine then, so if I did say another point here, so having 0 here doesn't make any difference. If I did say 3 to say 4 here, this would still be 3j, but 3 to 4 would be here up at 4 on the z, and it'd still be a 3. So it'd be pretty much this picture would repeat as you go up the z-axis. So here's a higher z value. You have the same picture as you're moving up. So just think of this as a river, and so go like this all the way up. So how you can interpret that is water on one side of the river flowing faster than the other side. So on this side it's flowing faster, and this side is flowing slower. And I guess right here actually, that's when x is 0, there'd be no flow at all. Because if x was 0, then there'd be 0 for your field. So pretty much it's not flowing here at all. And it's flowing the fastest as I'm moving to the right. And it's repeating like that all the way up. Okay, so now imagine we have a paddle wheel here. So this is all water in this area. So where would you have to point the paddle wheel so it would spin the quickest? Well, if I put it this way, it wouldn't spin at all, because you'd have the vectors of size 1 hitting down here and vectors of size 1 hitting up here. So it wouldn't spin at all. If you put it here, it wouldn't spin either. So I claim you'd have to put it here So if you at any point say here's your point P, I claim you have to point it up this way, because on this side you'd have a vector stronger than this side, right? Because as you move to the right, the current's getting stronger, so you'd have a stronger vector hitting here, would make this turn. Okay, and that would be the place where it turned the quickest. And it looks like the RPMs here would be, looks like one, looks like, because you got a 2 pushing onto here, 1 pushing onto here, so a difference of 1. And also if you put it over here, you'd have 3 hitting on here, 2 hitting it on here, so it'd still be 1. So it looks like no matter where you position it, the RPMs will be 1 to max the RPMs. If I turn it this way, of course, to be no RPMs. This would maximize the RPMs. And you can see this is sticking up in the Z direction. And it's also spinning counterclockwise. So if you use the right hand rule, move around with the paddle wheel, it's saying that the curl then should be in the positive Z direction. Okay, so let's verify that now. Okay, so let's verify a prediction. So we predicted it's going to point in the curl should point in the Z direction. So let's do the curl here. So the I component, so take this away and do this 2 by 2 determinant here. So it'll be partial operator Y acting on 0, then minus partial Z operator acting on X, I direction. Then we'll do J1 next. There's I. And then minus, so the J1 will be partial X operator acting on 0. Then minus partial Z operator acting on 0. That'll be J, then plus the K1. Cover those. So it'll be partial X operator acting on X, and partial Y operator partial Y operator acting on 0. Okay, so that's going to be 0. That's Z operating on X at 0, so it's going to be 0I, and that's partial X acting on 0, 0 at 0, also 0J, and partial X with respect to X would be 1, and that's going to be 0, so it looks like it's just K. So our physical interpretation gave us the right answer. And also if you look at the magnitude of the curl, well, just a K component is just going to be square root 0 squared plus 0 squared plus 1 squared, which is 1. And that's what we predicted for because this should be the max RPMs, and we predicted the max RPMs as 1. Okay, so let's look at another example. So here's our second example. So let's find a curl using the physical interpretation, then verify answer using definition of curl. So here our vector field, or our current, I guess we want to think of it in this case, is xi plus 0j, 0k. So I've drawn it here. So for example, let's do a point, say, so if I did f of 2, 3, 0, that means 2 in place of x, and then 3 in place of y, but there is no y here, so it'd be 0, j, and 0 in place of z, but there's no z here, it'd be 0k. So it's just going to be 2I, so 2, 3, 0, so it'd be 2 on the x, 3 in the y, so it'd be right here at this point. So that point right there, you draw a vector 2i, which I've drawn here. This vector is 2i because it's length 2 to 4. Okay, and I could also do 2, 3, 3, say. It would also be 2i because this has no z component, so you can put whatever you want for z. So this point then up at 3 in the z would also have length 2i, so it'd be the same as this guy, just shift it up. So pretty much at any level on the z-axis, it's repeating here like this as you're going up. Okay, so you can imagine now our paddle wheel. So if you think about it, then the current is getting stronger as you move downstream, because actually right here in the y-axis it wouldn't be to be no current at all. Then it starts to pick up, then it gets quicker, and over here it'd be even quicker, so forth. So you can think of maybe the water going down a hill. Yeah, so the water's going down a hill here. So maybe some sort of a waterfall or something, I don't know. Just some down. It doesn't have to be waterfall, just down some hill. So where would we have to position our wheel? Let's see. Well, if I position the wheel this way, for sure it wouldn't spin because to be hitting it this way, so it wouldn't spin. So it's going to have to be in this direction here somewhere. But here, if I let's say actually turn over this way, actually be looks like this way would be the best way. So I put it like that now. This guy down here would be hitting it down here. But if I come straight up, they're all going to repeat here. So you'll have the same size vector hitting it here also. So this vector will be hitting it down here, and the same size vector will be hitting it up here. So they'll prevent it from moving. So I'll let you think about it. If it has the current's getting stronger as you go down. Again, this has to be completely submerged. Of course, if it was on top of the water, then it would spin because it's going downhill like a dam. But this has to be completely submerged in the water, this paddle wheel. So if you completely submerge this in the water and the current's getting stronger as you're going downstream, uniformly getting stronger, this paddle wheel will not, actually no matter how you position it, it will not spin. So we're going to predict that the curl should be 0 for this guy. So let's verify that. Okay, so let's show the curl 0. So let's do the I component. So take this guy away. So if you did the I component, it'd be partial y operator acting on 0. So it'd be 0. Then partial z operator acting on 0. So minus 0. I. Then we do the j component. It'd be partial. Let's be minus then. Partial x operator acting on 0, so it'd be 0. Partial z operator acting on x, that'd be 0. And lastly, the k guy. So it'd be partial x operator acting on 0, 0. Partial y operator acting on x, 0. So you see the answer is 0. I guess you can write it as 0i plus 0j plus 0k. I guess you could just write it as 0. It's fine. So as we predicted, so you can see how we can use the physical interpretation to figure out the curl. Of course, if the vector field gets more difficult, then this physical interpretation way is not going to work. So we're going to have to just rely on the curl. So the curl is more powerful. Because if I made this a bit more complicated, it's going to be very difficult to figure out what the curl would be. Okay, so that's it.